Practice set 18, problem number 1. Determine angle A as shown in the diagram. The triangle is isosceles. We're going to begin by drawing an altitude from the upper vertex of the isosceles triangle to the side that's 15 millimeters. This will create two identical right triangles. Note that the altitude is bisecting this 15 millimeter opposite side length here. And if it's bisecting it, it's cutting it into two equal lengths. 15 divided by 2 is going to give us a dimension of 7.5 millimeters for both sides of the altitude intersecting this opposite side from the vertex it was drawn from. Having a side length and another side length, the legs of the right triangle, we have enough information to continue the problem and determine the measure of that angle. I'm going to draw just one of these right triangles then to continue on to solve the problem. We're determining the measurement of this acute angle in this right triangle that we've just brought down here. This leg has a measurement of 7.5 millimeters. This leg, because of the indication in the original diagram, has a length of 6.5 millimeters. And we're ready to label the sides of the triangle. Starting always with the hypotenuse, the side opposite the right angle, through the triangle opposite our reference angle, we'll label that the opposite, and our third side is the adjacent side. Going to the mnemonic so, ka, toa to determine which one of the trig formulas to use. We'll eliminate the hypotenuse because we aren't using that in this example and don't know any information about it. That means sine and cosine, which both involve the use of hypotenuse, are eliminated. That leaves us with the tangent ratio. Tangent of an acute angle is equal to O for opposite length over A adjacent length. We don't know the angle, so we'll leave the A by itself. Opposite has a length of 6.5 millimeters. The adjacent has a length of 7.5 millimeters. Simplifying the fraction by taking the numerator and dividing it by the denominator. In other words, taking 6.5 and dividing it by 7.5, we get a value of 0.866 continuing. Next, we need to get A by itself. To eliminate or undo the tangent, we will take its inverse, which is the arctangent of the tangent. Since we're taking the arctangent on the left, we will take the arctangent on the right to maintain equality. Arctangent of tangent leaves us with angle A, and we will use our calculator then to find the arctangent. And here, using this traditional scientific calculator, I'll enter that 0.8667 ratio first to activate or get to the arctangent, which is symbolized as tangent to the -1. I need to hit the second key and to activate the inverse tangent, which is above the tangent key. That gives me a degree measurement of 40.9 degrees for the angle that we're looking for.